so thanks again. I'm an associate professor of geography and sustainability studies at SUNY Geneseo near the northern range limits of the American chestnut. And my research generally is concerning the historic forest composition of the eastern U.S. As Fred nicely summarized, I'm interested in how Native Americans have managed forests to achieve desired landscape conditions. Can we, for example, see the imprint of cultural burning in historical forest data, such as higher abundance of fire-tolerant tree taxa like oak, hickory, and chestnut near areas of former settlement? I study these kinds of questions. I'm also interested in the historical distribution of chestnut. About 6 papers of mine have explored the historical distribution of chestnut in the Northeast. And more recently, I have become interested in the pawpaw or Asimina triloba, a tree notable for producing the largest edible fruit in North America. As mentioned, I am a geographer. Now, one stereotype of geographers is that we're only interested in memorizing state capitals. The field of geography is so much bigger than that, though. Geographers fundamentally ask 3 questions. First, what is where? We discover and describe geographic patterns across both space and time. Second, why is it there? After discovering and describing patterns, geographers assess causes to patterns they observed. And finally, why care? Geographers address the implications of their findings concerning the spatial distribution of a phenomenon and its causes. This talk presents a geographer's approach to mapping and understanding the past distribution of chestnut in the northeastern U.S. Using this lens, I use these 3 questions as the framework for my talk. First, I describe methods of reconstructing the historical range of chestnut. I will review methods that researchers use for reconstructing the historic range and abundance of the species. Second, why was it there? I cover some studies examining environmental and human factors that shape the historical range of chestnut. And briefly at the end, I explain the greater significance of these studies. In this talk, I also highlight studies on chestnut distribution in Western New York and the northeastern U.S. First, here is a brief history of the chestnut. The chestnut was an important tree of eastern North America, both ecologically and economically. It could grow over 6 feet in diameter, as these pictures show, and 100 feet tall. It produced large edible nuts, and its wood was prized by woodworkers. However, an invasive fungal blight from Asia was introduced in the 1890s and 1900s. It spread eastward, affecting chestnut across the entire range by the 1950s. This blight infects cambium of the tree trunk and develops cankers that girdle the tree, preventing the transport of water and nutrients. The main trunk dies, but the tree does survive. Stump shoots are reinfected when maturing bark begins to crack and furrow, where spores re-enter the tree. From the 1920s until present, efforts by scientists and nonprofits have sought to create a blight-resistant tree through breeding a pure American chestnut with blight resistance, back-cross breeding a blight-resistant tree that is mostly American, but with blight-resistant confirmed from Chinese chestnut, or through bioengineering a tree by inserting wheat genes that fight the blight. However, these efforts have recently experienced setbacks related to lab mix-ups, poor blight resistance in transgenic trees, the death of a leading geneticist, a schism between the New York chapter of the American Chestnut Foundation and the National American Chestnut Foundation, and also disagreements about whether any blight-resistant trees would be for profit or in the public domain. However, for this talk, I set these issues aside, and I will focus about the historical geography of the tree with a focus on Western New York. In the event that chestnut restoration becomes possible, these sorts of studies will be informative as to where we should reintroduce this species. I start by answering this broad question: where was chestnut located historically? This section focuses briefly on methods of geographic range reconstruction. Biogeographers and ecologists often lack structured data, such as forest inventory data, to reconstruct past species distributions. Instead, there are varied pieces of evidence to map past tree species distributions. These strands of evidence fall into natural archives, such as fossil pollen records, and documentary archives, like historical vegetation surveys and early land survey records. This diagram shows the spatial and temporal scales that these records can cover. Some can record changes over upwards of 10,000 years and over many square miles, but others provide more localized understanding of past forests. This table lists more documentary archives for reconstructing past ecological conditions, such as land surveys, legacy vegetation studies, historical maps, and herbarium records. This table also lists advantages and limitations of each. I will cover some data sources or methods for historical range reconstruction, including some listed here and previously, but I will highlight original land survey records listed first on this table, a noteworthy data source that I use extensively in my research. The list of data sources and methods I cover is not exhaustive, but it demonstrates the many means of mapping past distributions. One way to map the past distribution of chestnut or any other tree species is through palynology, the study of past fossil pollen. For millennia, tree pollen has fallen into water bodies. Scientists locate water bodies with ideal characteristics, such as small size and the absence of streams flowing into them, to collect pollen that sank to the bottom and was trapped in sediment. Here is Devil's Bathtub, a kettle pond near Rochester, New York. Today, a 12-inch diameter, approximately 60-foot tall chestnut tree grows on the ridge in the background of this photo. Here is a photo of a sediment core extracted from the bottom of a pond. And finally, here is a microscope view of chestnut pollen. By dating the layers of sediment and determining the relative abundance of pollen of different tree species in each layer, scientists can approximate when chestnut was present in a location and estimate how abundant it was. In a 1996 paper in Ecology, researchers analyzed pollen deposits at Devil's Bathtub. They established an 11,000-year record of the relative abundance of chestnut pollen and other species. They produced this graph, which plots years before present along the bottom horizontal axis and pollen of different tree species for 24 plant species on the other axis. This graph shows changes in the presence and absence, as well as abundance of tree species over 11,000 years, including the appearance or disappearance of tree species as plant dispersal progressed during the Holocene, the last 12,000 years or so. Here are two species, chestnut and beech. At this location, chestnut was virtually absent from 11,000 to 3,000 years before present, and since then has formed a minor component of forests. By comparison, beech, along with oak, which is not pictured, have been the most dominant tree taxa here for about 8,000 years. By mapping pollen percentages for chestnut at hundreds of locations where scientists have extracted sediment cores, and doing so for various times during the Holocene, we can track changes in the abundance and distribution of tree species. On the next slide, I show an animated map of chestnut pollen distribution and percentages over the last 21,000 years. Pollen records suggest that chestnut dispersed from a glacial refugium in the south-central Appalachian Mountains beginning around 13,000 years ago, dispersing northward and southward. It reached western New York in higher abundances about 3,000 to 5,000 years ago. The blue shading represents the retreating Laurentide ice sheet that covered much of North America. Despite the value of pollen records for understanding spatial and temporal trends in chestnut distribution, there are limitations. Some pollen cannot be resolved to the species level and can only be resolved to the genus level. The number of water bodies ideal for capturing pollen is limited, and some species produce more wind-borne pollen than others. Another source of historical data on the past distribution of tree species is early legacy ecological data, or legacy vegetation surveys. For over 100 years, scientists have conducted large studies to map species and vegetation communities. Noted early ecologists conducted surveys such as J.T. Curtis in 1950s Wisconsin and R.H. Whitaker in 1950s Oregon. In Western New York, ecologist Royal Shanks, that is his real name, and assistants conducted an ecology survey of the vegetation of Monroe County, New York, where Rochester is located. They surveyed from 1938 to 1940 using Great Depression-era funds from the Works Progress Administration and published findings of the survey finally in 1966. It is a unique survey that provides a snapshot of chestnut distribution just after the blight affected the region. Here's a woodlot analysis form from Shanks's survey. Within woodlots of 1930s Monroe County, they estimated the relative abundance of tree species, sometimes recording the condition of timber. They also assessed the woodlot's history, the amount of mature timber, and understory species. In area number 98, in the town of Webster, New York, on Lake Ontario, ecologists estimated that chestnut comprised 2% of trees in a forest dominated by white oak, sassafras, and other oaks. Notably, they also recorded the condition of chestnut trees as fair in this woodlot. Observations in other woodlots noted different characteristics of chestnut. Words like blighted, suckering, and sprouts also appear, plus language suggesting that some woodlots had unblighted trees. Compiling data from these forms, this map shows chestnut observations circa 1940. They observed chestnut in over 150 woodlots, though typically in low relative abundance. Later, I will cover how I use these data to understand historical chestnut distribution and some of the environmental correlates of the pattern that we see here. As valuable as these records are, they too, like other data sources and methods, have limitations. The woodlots that ecologists visited were not permanently marked, making it difficult to compare past data to current conditions. In the case of Shanks's survey, despite my best efforts, most of the woodlot forms are missing or are scattered among various offices and archives. Collectively, these surveys have incomplete coverage, representing singular studies in smaller study areas like county level. The final data source I cover are original land survey records. These records represent the best means of understanding tree species distributions just prior to European American settlement, as judged by their quality, spatial extensiveness, and systematic nature. Pictured here is a land surveyor from late 19th century northeastern, more like Midwestern US. Prior to the sale and settlement of North American lands, private companies and the federal government would survey the land, dividing it into towns and lots. These surveyors generally conducted surveys from the 17th to 19th centuries. These surveyors would record observations of landscape conditions, often according to a predetermined protocol. Though these records too exhibit data quality issues, they are an essential record of past tree species distributions. Fortunately for chestnut, its common name can be assumed to represent a single species. Also, it was an economically valuable tree species, meaning that surveyors may have been more inclined to notice and record the tree. Much of my talk, both in this section and future sections, centers on the usage of land surveys. Surveyors recorded observations within field notes. Here is one page of field notes from a lotting survey in Chautauqua County in Western New York in 1804, conducted by the Holland Land Company. Surveyors recorded many types of data. The township range and lot numbers are recorded, plus the direction and distance that the surveyor was traveling. Witness trees were trees used as survey monuments at important locations, such as corners of towns or lots. Surveying the wilderness, the most available monuments for surveying were trees. Surveyors would mark 2 to 4 trees at every corner by cutting their bark. They would then record the species, the quadrant, the distance between the corner and the tree, and sometimes even diameter, as we see on this slide. On this page, the surveyor marked 2 maple trees at the south end of the survey line at the top of the page, and 2 beech trees at the north end at the bottom of the page. Used as survey corners were posts also made from trees. On the left side, we see timber descriptions or line descriptions, which were qualitative descriptions of tree species observed along a survey line. As this survey traveled north, he observed an upland with butternut, white ash, and sugar maple. He then crossed a swamp with birch and black ash. Finally, he entered another upland area with soft maple, basswood, and elm. And then finally, a forest of hickory, chestnut, white oak, and black oak. These field notes can be matched with modern tax parcel data. These original land survey lines served as the early property boundaries, and their geometry persists in modern tax parcels. revealed when we compare historical survey maps with modern tax parcel data. I have circled in here the endpoint of the survey line described on the previous slide. My work mapping survey lines occurs within Geographic Information Systems, or GIS software. Assisted by GIS, researchers link transcribed field notes with mapped survey lines. Here are those descriptions from our example field notes mapped. And notice at the top is our reference to Chestnut with a green arrow. We then repeat this process over and over again. Shown here are all the original lot lines in Chautauqua County. And for my dissertation, I spent months transcribing every page of land survey records in Chautauqua County. Just to give you an idea as to the amount of data recorded just for one county, this totaled about 3,900 pages of field notes, about 5,800 timber descriptions. These timber descriptions contain collectively nearly 20,000 mentions of tree taxa for an average of 3.3 tree taxa per description, and also about 6,500 witness trees being those trees that were marked at the start and end of survey lines at important property corners. This map shows the locations of where surveyors used a chestnut tree as a survey corner, symbolized with a black point, or listed chestnut in a timber description, symbolized with a thick black line. In this manner, we can estimate the distribution of chestnut just before white settlement. I will circle back to this map in the next section when presenting a study that assessed factors shaping the distribution of chestnut shown here. Many researchers have used land survey records to map past vegetation patterns. For example, in 1992, researchers Marks and Gardescu published Vegetation of the Central Finger Lakes region of New York in the 1790s. They transcribed land survey records across the 28-town military tract in the Eastern Finger Lakes region, containing the modern-day city of Syracuse and the territory of the Onondaga and Cayuga nations. This table presents the frequency of different tree taxa recorded in timber descriptions, termed bounds here on the left, and as witness trees. Chestnut was observed on just 4% of the 2,800 miles surveyed and comprised only 0.6% of witness trees. Again, here at the northern limits of chestnut, the species was relatively uncommon. In the Eastern Finger Lakes, this region was dominated by beech, maple, basswood, hemlock, ash, and elm. This map of the military tract shows where surveyors marked chestnut as a witness tree or mentioned the species in a timber description. Squares show where chestnut was observed on a survey line, and dashes, which are very rare, show where chestnut was used as a survey corner. Though chestnut was uncommon, there are interesting patterns here. Chestnut generally appears atop the southern hills of the region in areas closer to traditional Cayuga and Onondaga settlement. Some have suggested that forest composition here, comprised of chestnut and other fire-tolerant trees like oak and hickory, are indicative of cultural burning, a theme I will explore again later. Some researchers have transcribed witness trees across the northeastern US, aggregating these tallies per town to create maps such as these. Each pie chart represents one town, and each slice of the pie represents the relative abundance or percentage represented by a single tree taxon, taxon meaning typically genus level or species level. This map is dominated by beech in dark red, maple in medium red, and oak in gold. Chestnut is shown in light yellow. As an example of a single town, I point at the town of Naples in the Western Finger Lakes, where chestnut was the second most common taxon recorded, behind only oak. 16% of all witness trees were chestnut here, making it perhaps the location with the highest abundance of chestnut across Western New York and the Finger Lakes. In the northeastern US, chestnut formed a smaller percentage of trees and was more common in southern deciduous forests alongside oak, hickory, and some maple. This map represents a general snapshot of chestnut distribution, and at finer resolution, we would observe more precise niche preferences of the species and its association with other species. The availability of original land surveys is patchy in the northeastern US. The field notes of surveys are housed in libraries, archives, and even private collections. Some sets of field notes have been lost or destroyed through the deterioration and decay of paper. To produce continuous estimations of a tree's relative abundance, researchers have used advanced statistical interpolation methods. This map shows the relative abundance of chestnut ranging from 0 to over 20% of all trees, estimated from witness tree tallies. Witness trees, once again, are those trees that were notched or scraped with axes at the corners of lots in towns by land surveyors. Darker green represents a higher abundance of these witness trees, and a lighter green represents a lower abundance. Notice that there are gaps in coverage where these researchers did not collect land survey records. Using interpolation, researchers produced a continuous estimation of chestnut abundance, where every 5 by 5 mile grid cell, or roughly 8 by 8 kilometers grid cell, was assigned a value. Here in Western New York, there were many places where chestnut was virtually absent. In much of the region, chestnut was only 0.1 to 5% of all trees. However, in some more localized areas, chestnut made up 5 to 20% of trees, such as in portions of Allegheny State Park, as well as in the Allegheny Uplands and into Allegheny County. So in conclusion, we see that there are various sources for reconstructing the range of past tree species like chestnut. All of them have their limitations, but ultimately it is these land survey records that many researchers resort to in order to understand the past distribution of trees like chestnut. Part 1 of my talk covered methods and data sources for mapping the historical range of chestnut, focusing on land survey records. Part 2 now addresses questions like that geographers and other researchers answer that are more the why type questions. Why was chestnut observed in these sorts of distributions? To begin, my 2020 paper modeled the historical distribution of chestnut specifically in Western New York, both to understand which factors shaped its range here and to predict where chestnut was located exactly. This study demonstrates one use of chestnut observations in land survey records. As data for my models, I used observations of chestnut in field notes of the aforementioned Howland Land Company, specifically their 6 by 6 mile township survey that was conducted in 1798. This map shows the township lines that typically divided the region into those 6 by 6 mile townships, but with some irregularities as well. Every few miles, I sampled timber descriptions to determine if chestnut was observed growing at that location. Darker points here show where chestnut was recorded. I then compared observations to several climate, soil, and terrain variables. This slide shows 4 of those variables: growing season precipitation, January temperature, growing season temperature, and soil drainage. But my modeling included 19 total variables. Chautauqua County, which was discussed earlier, is outlined in the southwest. I employed a set of techniques called species distribution modeling. This technique numerically relates species presence and absence locations to underlying environmental factors illustrated on the left side of the diagram. Next, these techniques select variables that are most correlated with species presence absence and also characterize the relationship between presence and absence and these variables, shown at center. Finally, models are applied to make continuous predictions of the suitability or probability of presence for a species based on relationships with mapped factors, shown on the right. For this study, I employed 9 different modeling techniques in a method known as ensemble modeling. Models were developed through the joint use of GIS software and data with statistical programming in R. This map shows the predicted suitability for chestnut in Western New York based on models. For reference, we see Hornell is labeled there toward the southeastern corner. The darker the green, the more suitable a location is for chestnut. To create this map, the predictions of each of 9 models were converted into a binary suitable or unsuitable prediction, and the map shows the number of models that voted suitable for that location. The models overall were not very strong, suggesting that the distribution of chestnut may not wholly be based on environmental conditions, and may instead be influenced by disturbance such as fire and wind throw, or is sensitive to climatic fluctuations here at its northern limits. However, two variables that models consistently chose as strong predictors of chestnut distribution were terrain slope and soil pH. Chestnut grew in steeper terrain and atop acidic soils within the study area. And you can see here in the Alfred vicinity, there was a high suitability for American chestnut. Whereas that study only examined environmental factors, such as there are other studies out there that have additionally examined human factors that might also be related to the distribution of chestnut. One of the first papers to do so was this paper by Black, Ruffner, and Abrams entitled Native American Influences on the Forest Composition of the Allegheny Plateau, Northwestern Pennsylvania. This team mapped witness trees circa 1800 in northwestern Pennsylvania, where the Seneca Iroquois and other indigenous groups were living. This map shows oak, chestnut, or hickory witness tree locations with black squares, which I kind of circle there in green, other witness trees as white circles, and then finally Native American towns as white triangles, which I circle in purple just to emphasize. Also shown in this map are white lines that represent travel routes. Using a regression model, this team assessed the importance of 6 variables to the distribution of oak, hickory, and chestnut combined. These variables were aspect, elevation, slope, geology, landform, and a Native American index, or NAI. This index estimated how much a location was influenced by indigenous land use, such as forest burning, ranging from 0 to 100, and based on proximity to towns and travel routes. Their analysis found that 3 variables were significantly correlated with oak, hickory, and chestnut distribution combined: geology, landform, and this NAI, or Native American Index. Areas closer to Native American settlement and on mid to upper slopes and atop certain geology types had a higher probability of oak, hickory, or chestnut. 3 taxa that indigenous societies promoted through cultural burning in order to produce nut production and to create an easily traversable hunting ground and landscape. In a similar study in 2015, my PhD advisor and I modeled the distribution of chestnut and other trees to understand factors shaping past distributions. Whereas the previous paper grouped oak, hickory, and chestnut together, our study modeled chestnut distribution separately. Our study area was Chautauqua County, New York State. For occurrence data, we used survey observations of chestnut shown in this map, specifically the timber descriptions shown as black lines. Again, we compared the chestnut observations to environmental variables. And again, we employed species distribution models to understand the importance of and relationships with environmental factors. However, we also compared chestnut locations to Native American geography, such as town sites and trails, shown here. We sought to develop a rigorous measure of where Native American land use was more likely to occur. What we did is we estimated how many calories a person would burn traveling from every location into our study area by foot to the nearest historic town, the white circles, nearest late woodland town, the gray squares, and nearest trail, the dashed lines. We term these Native American variables. By including these measures of human accessibility in our models, our predictions of chestnut distribution better match the actual locations of chestnut observed in the survey records. The left column of maps shows the surveyor observations of chestnut along with white oak. The middle column shows predictions for these 2 species where Native American variables were excluded in models. Whiter indicates higher probability, whereas darker indicates lower probability. And the right column shows predictions where these Native American variables were included in models. Notice the improved match between actual left and predicted right chestnut distribution. Also notice the correspondence between Native American towns on the left and, on the right, and chestnut distribution on the left. This study found that at this resolution and geographic extent of analysis, Native American presence best predicted chestnut distribution. Most notably, within 6 to 9 miles of 18th century town sites, the probability of observing chestnut increased. Results suggest that toward the northern limits of chestnut range, Native Americans were actively promoting chestnut in localized areas, perhaps through cultural burning or girdling of unwanted tree species. At its northern limit, chestnut may have otherwise been outcompeted by northern tree species like beech, maple, hemlock, etc. The line of chestnut observations parallel to Lake Erie, shown in this map, was likely driven by well-strained acidic sandy soils. However, note that a major indigenous trail also ran atop these same soil conditions. Some of you may wonder what these cultural burns may have looked like. Here is a forest fire in spring 2023 along Canadice Lake in the Western Finger Lakes, which I think represents the low-intensity, smoldering quality of these burns. These fires were not the large stand-replacing fires seen in the Western U.S. My Chautauqua County study examined relationships between chestnut, climate, soil, terrain, and Native American settlement across a small study area. However, in another study, 4 undergraduate assistants and I asked the question, did Native American settlement shape tree species abundance across the entire northeastern U.S.? In our 2022 paper, we tried to answer that question, but as the title suggests, we found evidence only for local level increases to chestnut abundance near settlements. For model training data, we used chestnut abundance shown in this map, estimated using interpolation and based on witness tree tallies. Again, we used statistical modeling, species distribution modeling, and we compared these sorts of data layers to 27 climate, soil, and terrain variables. We also compared patterns in chestnut to variables representing Native American land use. We attempted to come up with different representations of where people were living before Europeans arrived. This map shows the Native American geography that we mapped in GIS. Archaeological sites, towns, and settlement areas circa 1500 to 1800. To develop numerical variables, we simply calculated the distance to nearest feature for each layer of indigenous geography. Our analysis found that within roughly 6 to 30 miles of Native American settlement, there were modest increases in the abundance of fire-tolerant vegetation, including chestnut. However, our modeling suggested that other environmental variables were more important in shaping geographic patterns in chestnut at this larger scale. Listed here are some predictors that were more important or that showed clearer relationships with chestnut abundance. Chestnut was found in warmer climates, in locations with average annual temperatures above roughly 43 degrees Fahrenheit. It grew atop younger, undeveloped, coarse-grained soils, and it grew on steeper terrain. Collectively, these results reaffirm previous studies. Chestnut grew in warmer upland acidic locations atop coarse-grained soils. Chestnut may have been actively managed by Native Americans, but often in environments already favorable for the tree species. Returning to Western New York, I recently published a paper in Forest Ecology and Management, in which I modeled the mid-20th century distribution of chestnut in Monroe County. As training data, I used the observations of chestnut made in the Schenck survey of 1938 to 1940, unique in that most chestnut modeling studies have either studied the pre-European distribution or the present distribution of remnant trees. Recall these data sheets and map. Using modeling techniques described previously, I compared these observations to underlying soil, climate, and terrain characteristics, both to understand species-environment relationships and to predict suitable areas for the species. Here is an elevation map of Monroe County with chestnut observations from circa 1938 to 1940 mapped. Green represents lower elevation and brown represents higher elevation. And on this slide are some of the relationships that models discovered between chestnut suitability and environmental conditions in order from most to least important. Chestnut grew once again atop well-drained, sandy, acidic, nutrient-poor soils, but also in areas that received higher solar radiation and possessed deep soils. In particular, we see that chestnut grew in soils with some of the fastest permeability rates in the county and in soils with a pH of roughly 5 to 7. And here is a map showing modeled chestnut distribution in Monroe County. Darker green indicates higher suitability, and purple points are the mid-century observations of chestnut. My models predicted that chestnut concentrated along Irondequoit Bay, and in the towns of Irondequoit, Webster, Penfield, Pittsford, and Parenton, with more sporadic patches elsewhere. The third and brief final part of my talk is to leave you with the big picture implications of some of these studies. Perhaps most relevant to current chestnut news, these studies refine our understanding of where the species grew historically, producing valuable knowledge in the event that chestnut restoration becomes scientifically possible, ecologically beneficial, and societally desirable. Second, the summarized studies have challenged the myth that chestnut was overwhelmingly dominant. Sometimes you hear that 25% of all trees in the eastern US were chestnut, for instance. Yes, it was dominant in some portions of its range and even locally dominant in pockets in our region, but not overall dominant in Western New York, where other species like beech, maple, hemlock, basswood, and ash were and are more common. And forests more southerly were dominated predominantly by oak and hickory. Finally, these studies reveal connections between the chestnut tree and indigenous cultures. As shown by at least 3 studies, in addition to traditional ecological and other vast bodies of literature, there is an important cultural link between chestnut and indigenous communities, showing that forests were managed to produce chestnut. Chestnut restoration may offer a chance at something called reciprocal restoration, the revitalization of ecosystems as well as cultures that historically depended on the tree. However, indigenous communities may be rightfully cautious of these different trees, especially those bioengineered. Thank you. Happy to take any questions.
So when you mentioned correlations between the locations of the chestnut and the Native American settlements, you suggested that they would manage for them. Any possibility that something else unrelated might happen, like deer population in proximity to the settlements would be depressed, allowing more recruitment from those trees to occur?
Yeah, I mean, I think cultural burning had cascading benefits. And I don't think there was any one reason to burn. And I have even seen lists of 90-something reasons why cultural burning was useful. I think absolutely opening up the understory could have benefited chestnut seedlings, oak regeneration. There's also growing literature on berry production as well in these semi-open environments, strawberry production, blueberry production. So absolutely, bringing in deer, like you said, increasing mass production. Chestnut, oak, hickory, a lot of these species produce more seed when they're growing in more open conditions and have less competition, and that could bring in deer as well. So yeah, certainly just cascading benefits for burning and clearing the landscape. Does that answer your question? Okay.
Oh. Yeah, you talked about the use of the land survey records, but you also mentioned some other types of resources or records that could be used. Do you ever use several of these to corroborate what you're finding?
Yeah, that's a great question. And that's something that I really enjoy being a geographer for. Geographers, I think, are just in our nature very interdisciplinary researchers. And I usually try as hard as I can, regardless of what sort of methodological approach I use in my research, to, within the paper and the discussion, bring in those other resources, those qualitative descriptions, maybe early traveler accounts. And I've done that somewhat with my own chestnut research. I'm thinking, for instance, of the Chautauqua County study. There was a gentleman by the name of David Thomas in 1816, and he traveled that route along the former beach ridge of Chautauqua County, where there was all those chestnut observations. And he specifically said that there was a uniquely high amount of chestnut. So yeah, that's always sort of a fun part of my research is just the corroboration. Also, some of my other research looks at oak savanna distribution, which is this globally endangered ecosystem type. And part of my research was to use these sorts of quantitative methods, but then also bring in the early pioneer accounts to see if they were actually describing open conditions. So, yep. Great question.
Much as you, and just then that's the people who tend to congregate. So is it coincidental that people congregate along the river, or does not congregate along the river? Looking at that map, Pittsburgh, there's kind of a string of dark green.
Yeah, that's an excellent observation. I think it's just a suite of interlocking factors that elevates chestnut abundance there, right? It's going to be a little warmer down in the valley as opposed to the hilltops. And that's also where human settlement is focused as well. The Black, Ruffner, and Abrams paper from 2006 is from that very location that you're describing. I'll point to those of you who are in person here, right there. I think that's the location you were talking about. Yeah. Yeah, so you'll see these really interesting kind of almost like peninsulas of mast-bearing tree species. So oak, hickory, chestnut that occur in these river valleys, but also where there was Native American settlement. So I'm also thinking of some of the river valleys kind of in central New York down here along the Pennsylvania border. And that, yeah, again, it's, I think, kind of a mix of climate as well as human land use. I can very clearly kind of imagine, you know, indigenous people settling these areas, burning off the land for agriculture, having that fire escape into the uplands and, you know, clear out the underbrush and also benefit chestnut trees kind of on those mid slopes adjacent to their farm fields. Yeah, great observation.
Thank you for the nice history.
These are amazing questions you're all asking. Thank you. This is like one of the best set of questions. Two sources I can think of. One is iNaturalist, which some of you in the room may use. It's like a citizen science app, and you can record your own observations through AI. One of the better uses of AI, it identifies the species for you just based on image recognition. And then in the community, they can confirm the species that you've identified. That has produced thousands and thousands of observations of chestnut. Actually, I can think of three sources now. There's the GBIF, the Global Biodiversity Information Facility, which is a collection of museum samples, herbarium records, but also iNaturalist pulled in. And then a little more inaccessible is the Forest Inventory and Analysis Database, which the USDA Forest Service puts together, where they have a network of hundreds of thousands of plots across the US, where they've recorded in great detail the tree species found there. That's just a little more inaccessible, but there are some resources online where you can perform queries and try to find it, specifically for chestnut. Yep. And then the USDA Forest Service has also made the Climate Change Tree Atlas, which you can find maps sitting on websites that show you current distribution of chestnut. So I believe ESF is sort of the leader in the transgenic chestnut, where they're looking to insert wheat genes in it that confer that blight resistance. And coincidentally, I just reviewed one of their papers like a couple months ago. And the issue with the American chestnuts that are transgenic is they're blight resistant, but they're ending up being smaller in stature than they would like. So as I mentioned early on in that timeline, the 2020s have been a rough time for chestnut restoration. They've had a lot of black eyes just in terms of, the lab mix-ups, the loss of that leading geneticist, and schism and just sort of the philosophical side of how to restore American chestnut, whether it's through back cross breeding or the genetic engineering. There's been a lot of turbulence in this effort, but yeah, they are moving forward, and I think there's other maybe kind of corporate interests as well in developing these blight-resistant chestnuts as well. We'll see where it goes. It's not a great moment though right now for American chestnut restoration. I'm definitely more on just sort of the knowing about its historical ecology.
One last question after that.
That it came over on like a boat, or is it like, was it introduced like accidentally through like, I don't know, like tools and?
So there's a book called American Chestnut: Life, Death, and Rebirth of the Perfect Tree, maybe, by Susan Frankel. And it's an amazing cultural history of the American chestnut. They think it came over in nursery stock from China or Japan, and it started in major cities. So I think New York City was one of the epicenters of the blight, but I think they also think it also started in a couple other East Coast cities. Yeah, so it was just people looking to plant Chinese and Japanese chestnuts, and unfortunately it made its way over. You're welcome.
Thank you very much for your presentation.
Thank you.
Just heads up in front here, there's some roasted chestnuts. If you had never tried it, there's still a few left. I give it a
I've
try.
never tried them.